Good evening. How's the volume? Good? Not too loud, not too quiet? Perfect. All right. I'm Angela Metler. I'm an administrative assistant at South Dakota Mines in the president's office. Thank you for coming to Steam Cafe tonight. Steam Cafe is a partnership with Hay Camp Brewing and South Dakota Public Broadcasting. So we thank them for their support, and we thank you for your support as well. We do this every third Tuesday, and we always broadcast live on Zoom. So thank you to those of you who are attending on Zoom. At the end of the presentation, we will do a question and answer session with our presenter. So if you have a question, raise your hand, he'll get to you. If you're attending online and you have a question, please type your question into either the chat box or the Q&A box, and we will make sure that it gets answered live. So that's it. Without further ado, tonight's presenter, Dr. Patrick Kozak.
All right. Well, good evening. I am Dr. Patrick Kozak. You can call me Patrick. You can call me Kozak. I've been called a lot of things, doc, professor, things. I am an instructor and research scientist at South Dakota School of Mines in the Chemistry, Biology, and Health Sciences program, but also in the Environmental and Atmospheric program under civil engineering up there. So tonight I'm going to talk a little bit about, I am making some ringing. I am talking a little bit about one of the projects and research projects that we have that is of importance locally for us, and it's talking about the Bentonite Moonscape. So this is an area up just northwest of Belle Fourche, South Dakota, and I'm going to talk a little bit about what we're doing up there and why we're doing it as we go through. But first and foremost, I'm probably the wrong person to be up here tonight because this is the National Day for Women in Science and Engineering. And so I want to make an acknowledgement for all the women who are in science and engineering and what they do, because I think it's phenomenal and it should be. So just one of those lucks that this is the one I get to do today. So I'm talking about it. That is the area out off 212 that's called the Moonscape. Hence the picture and the look. We'll talk a little bit more about that as I go through. I have a couple of scientists that work with me. Dr. Lisa Kunza, who is a biologist in the Chemistry, Biology, and Health Sciences program, and Dr. Jennifer Walker, who spent 20 years with the Bureau of Land Management as a spatial ecologist, who then stepped in with me and us after she retired there and started working with us on these projects out there. So we are funded and work through the Center for Sustainable Solutions at the School of Mines. We're a kind of a unique center because we were driven by the research scientists and faculty on campus. So there's about 20 of us that have come together and started this center with Lisa, Dr. Kunze as our director. There's about 23 of us. We work on projects that relate to sustainability, including water, land processes, cultural sustainability programs. All of those things kind of fall in here under what we look at because we have an understanding that this is a multidisciplinary need. You need more than just one group of scientists or people to kind of figure these things out. So that's us. And there's some more information if you're curious, and I can talk to you about it. All right, so we're going to talk about bentonite mining. We're going to talk about bentonite mining specifically in northwest South Dakota. So it started here in the early 1900s, right? As you can see, I actually have a laser pointer. So it's documented and then commercially viable in the 20s and 30s when they started working up there. That is an actual historic from about 1920 of one of the piles at Colony, or actually at Upton, Wyoming, of one of the bentonite covers. So bentonite, as you all may or may not know, kitty litter. So it's a swelling clay. That's really one of the big uses for it. But it has a lot of other uses. It's used in cosmetics. It's used in drilling muds for fracking and other things like this. It has this great quality, which is why it becomes well for kitty litter. It gets wet, it absorbs that, and swells. So it's a swelling clay called a smectite. So it's this kind of thing that we see in here, and it's of importance. It's made from a volcanic ash layer that was formed in the Pierce Shale out here. So a very old unit, and it runs from just outside of Belle Fourche all the way through Wyoming and into Montana in the Belle Fourche Shale. So we have Belle Fourche Shale here. In fact, the School of Mines is sitting on Belle Fourche Shale, which is one of the units of the Pierce Shale. But here, that bentonite is much richer and mineable in amounts in this region. And how you mine it is you literally go in, you scrape off the dirt, you scrape off the topsoil, you scrape everything off, get down to that layer of bentonite, you dig it out. You screen it for really big things, big concretions or anything like that. They get thrown back over on the land, and then everything else gets shipped up to Colony for processing. That's the traditional way that has always been done. However, back these days, you didn't have regulatory requirements for how you did stuff. So that mining up there was done just moving, pulling, and dumping, and then not cleaning up afterwards. I'll talk about that a little bit. So this is where it's at, just northwest of Belle, right along 212, and it really does extend up to the Wyoming border. However, you see that landscape that is moonish or moonscape in style, but you notice something else in these pictures. I'm going to talk about that. There's water up there, and there's a lot of water up there. And it is a different ecosystem as it's grown and established over these 100 years through mining. So it's different than what you would think for a traditional reclamation type area. That is Ashley Hall. She is one of my graduate students actually doing water quality measurements out there. But you can see the riparian growth and the vegetation that's out there in the landscape. So the issues up here, almost all mining prior to 1970 and Clean Water Acts and those types of things didn't follow regulatory cleanup requirements or have bonds for cleanup post. So these areas were done. They scraped, they dug out the bentonite, they moved to the next. Scraped, dug out the bentonite, moved to the next. Well, you're in bentonitic shale, so you're in clays. One of the uses of clays is impermeable liners for ponds. So all of a sudden you have all these ponds up there starting to form, disconnected to the landscape as we talk about those types of things. Some of these can be quite large. The other areas where they're still actively mining, this is what you see. That's the bentonite, that whitish clay in there. That's it as bedrock. They'll pull it up and break it down and make it uniform, and that's what goes out for commercial use. So past research was done up here. Montana State, the BLM, and the NRCS got together and started looking at ways to remediate this area in the late 70s, early 80s. We live in an area that is arid, and it used to be a big sea. 65 million years ago, we were the Cretaceous Interior Seaway, right? Well, what do seas have in them? Salt. What happens when the water dries up? Those salts become evaporates and settle down and in. That's why we have gypsum, all of these kind of things in here in the layers. All those are salts. Salts on the landscape have issues and problems, and we'll talk about that in a minute. But when they came in to do their work, they made some assumptions about the soils and the conditions here and what they were going to do, and I'm going to talk about that. So what they did and how they did it was a lot of chemical treatments to try and remove the salts out of the area. Well, 65 million years we've had salts in our landscape. The vegetation that is here and is native has grown, adapted, and lived with those salts on the landscape. They manage those situations. They're tolerant. They're called halophytic, some of them. They're salt tolerant. So that's what lives here. So if you try and change that, the salt's going to come back and you're going to have problems. And that's kind of what they figured out when they went through some of these things and looked at them in the 80s and 90s. The other thing they did is they used untenable amounts of sulfuric acid and organics. The sulfuric acid was to migrate and move the salts off and condition the soil. Because the other thing that soil is out here, or clays are out here, is what's called dispersive, and I'll talk about that too. They flour and fall apart. They don't grip and hold like clays do in a lot of cases, which causes erosional problems and doesn't allow you to get water in. So I'll talk about that too. So these were all problems that they started looking at and trying to figure out how to resolve. And one of the ways you traditionally do that is you add sulfuric acid down, organic matter, and you start to build soils. They were putting down literally volumes, hundreds of gallons of sulfuric acid for small square patches to try and clean this out, and then they came back 10 years later and the salts were right there. So it was not a great way to do it. So one of our jobs is to come up here and figure out over a 3-year project, how can we remediate this? The original plan was to go in and remediate it the way very traditional remediation is done. You put it back to a reference state. So it goes all the way back to what is natural. Well, we have a long conversation, and everybody in this room has a different view of what natural is. Some of that's based on age, some of that's based on your experiences. It's called shifting baseline syndrome, right? What we see and know as natural. But that's not always the case. A good example of that, how many of you guys have ever heard of kudzu? Yeah. So kudzu is an invasive species all over the southern U.S. Most people who are under the age of 35 or 40 have never lived without kudzu. So for them, that's what it's always looked like. But it's not. It's an invasive species. So these are the kind of things we talk about when we're talking about remediation is what's the reference state or where do we want to get back to? This has been here for over 100 years. Are we going to get back to a reference state? We probably could by spending a lot of money, but that's not going to work either. So we're going to have to figure out a more equitable way to do that. All right, so here's the study area coming up. You can see that light gray right there, that's the bentonitic shale in the Belle Fourche. This area is the Niobrara shale, which is different, does not have bentonite. And then you have a sheer cliff drop off over here. That's the Belle Fourche River down in the valley there. Very different. It's just this one ridge where that bentonite is. You can see that gray area there. That really bright blue, those are the water bodies that are up there. So that is not a natural state for western South Dakota to see that much water on the landscape. What you see here up on this road, on the north end here, there's a small road that you can't see here called 3V Road. That's the road. That's the bentonite area. That's the shift over to the Belle Fourche or the other Pierce shale unit. You start to see scrub oak, pines, all these kind of things. And that's a demarcating where you've got a different soil structure. So the mining is here. So the original people came in and saw those pine trees and that scrub oak and they're like, that's what's supposed to be here. Well, it's not. That's this unit here, not the unit down below. So, like I said, shifting baseline syndrome, what is natural? So this is one of the things I do when I teach classes and I talk about this and I talk about natural appearance and stuff. This is a great picture from the Custer expedition and then Paul Horsted looking back, over 100 years at the amount of vegetation increase. Why? Well, we suppressed fire for 100 years because we love trees and Smokey taught us. Only you can prevent forest fires. So we did those kind of things. But what it did is it increased the ponderosa pine structure and everything in the hills from what a natural fire regime is supposed to be. So your reference state, do we want to go back to this or is it this? Well, for fire, we want to go back to that, but here we want to look at this. We as people get to make that decision. That's one of the things that's really important when you talk about remediation and reclamation. It's really our decision and discussion for where and how we get that back. So this is what it looks like today. Those are those scrub oaks sitting out in that area. This is the distribution of water bodies just down the center run of that bentonitic area. So every one of these different slightly colored areas, those are all water bodies. They were all mined out. Those are mine pits. They've been mine pits like that for 100 years. They're not filling in. They're sitting. There is sediment settling down in them. They have active wildlife in there. Snapper turtles, this big. I was trying to find a picture of one. You just see a robust ecosystem that's radically different up here. So you have to look at those things. But that's not natural for this area. You start to see this. This is Middle Creek. It's controlled, it's flowed, it's very green, lush, wet meadow. That's kind of what western South Dakota is supposed to be a little bit more of. Not open water bodies, but wet meadows, grasses. That's where your bison would have came in, hit, and then left. Not stock ponds, not those types of things. It's okay. It's where we're at and what we've done. But this is what it looks like. So pre-mining, there wouldn't have been any water up there. So the cost to remove that water would be outrageous. So we have some ideas about that, and I'll talk about that in the middle. The last part about this is western South Dakota. Part of my love for conversation about this here. Just as a curiosity, does anybody know how many natural water bodies there are in western South Dakota?
0.
Nope. 3. How many of you have heard of Cox Lake? That's Cox Lake. It's just outside of Spearfish. It's a sinkhole. So the karst came down and formed a water body and sinkhole. There's 2 more, Mud Lake and Mirror Lake. They're all karsted. They're all wrapped around the outside in the Minnelusa around the Black Hills. Those are the 3 that are actually not man-made in the hills. So we don't have water usually. Even our rivers and creeks are ephemeral by nature, except we've dammed up Pactola, Belle Fourche, and we regulate flow, so we have year-round flow. That's not how natural is supposed to be, but that's how it is. So again, we get to define natural or the reference state we want to go to. All right, so the area we're looking at is really been worked over and damaged over the years. So this is an area that we mapped out using imagery. So this is from an airplane. It's called NAPE. So it's got a 1/2 meter resolution. So think about your camera. Take a picture, you zoom way in, see that pixel? Each one of those pixels is a 1/2 meter on this data set. So it's pretty fine resolution. Can I see people? No. Can I see cars? Well, I can see the outline of a car, but that's the kind of thing. But what you can see is this is the map by the NRCS of the mine and pit areas that have been worked on. You can see where the water bodies are as they run down and through. You also see this is what's called a principal component analysis. So it's an image where I've taken and changed the colors from red, green, blue, and near infrared to maximize some of the differences that we're looking at, so I can classify them and start to pull out information on what I'm looking at. And that's what's here on the end. So what that tells me is I can do a pretty quick and good job mapping where the disturbed soils are and where we want to look at for potential plan for mediation. But it's still pretty coarse. So in that area, like I said, water bodies. So there's about 80 water bodies in about a 4 or 5 mile stretch. Some of them are very small, almost silted in. Some of them are 10, 15 feet deep. And actually, the BLM is very interested in making fishing, cold water fisheries up there on some of these because the water is pretty good and they're large enough. And a lot of the area we're looking at, all that hash gray area, that's BLM land, so that's public lands. So we started talking to them about looking at this and looking at the soils and the water of the area to answer some of these questions we were talking about. We also worked with the EPA on this. Why did we work with the EPA? Because it's an abandoned mine site. So they wanted to see if there was hazardous minerals or other things. So what they do is called a pre-surface screening, so they can find out if it's going to be a Superfund site or something like that. So they came out with us on their dime and did our soil testing and some water testing on the front end so we could start to look at these things. And these are the areas and locations that we put through for testing in the areas with them. We did soil and water and did a whole bunch of things to look at them. Then we went back out with our undergraduates and grad students and went out there and started looking at usage. Also soils. Is wildlife using it? Are livestock using it? Because there are cattle that are run up and through this area. How is it being used? Is it a functional ecosystem? All these kind of things we went through and started to look at. So when we got there and we started looking at the soil and the landscape, salts. That was the initial appearance. You guys have all driven through western South Dakota, actually all the way down to Texas, and seen white crusts now starting to appear more and more on the landscape. That's salt from the Pierce Shale. Those are salts that are coming up. They get released, they flow down in the water, and then they settle in low-lying areas, and you get those salt crusts. So if you ever walk or ever drive up Old 85 or go through 212, and you look where a stock pond is or a stock dam, and you see down below, you'll see those areas where you'll see that salt. It's natural in the landscape, though we're increasing that solution. And it can become toxic for wildlife and livestock. The other thing we do is that dispersivity. When you have a lot of salts, clay lumps together and holds together really well, right? We make pottery and stuff out of it. If it's dispersive, it has a lot of salts in it, it turns into this, and it just basically becomes flour when it gets wet. So it doesn't hold water or stick together, which you would think, oh, that's going to be great. It's going to infiltrate. Water's going to get down to the ground. It doesn't, because it packs. And it packs so much tighter, water can't get through. So it almost becomes an impermeable layer on top, so you don't get water and infiltration. You don't get soil development. So we have to look at these things here for how this soil is, whether it has too much salt and the type of salt, and whether it's dispersive. So this is what happens with normal clay versus a dispersive clay. And you get those clay pans that you see out here all over the place in western South Dakota. All right, so we went through and we tested water quality out there in addition to the EPA. And I'll talk about our stuff first, because one of the things that is always discussed is the toxicity of water and surface water out here. So when I've done work up there for almost 8 years now, looking at water quality in Butte and Hardin counties, I have water that ranges from about 5,000 microsiemens per centimeter. What's that mean? It means how well electricity can go through your water. Conductivity. More salts, more electricity gets through. Less salts, less electricity. Higher number, more salt. Lower number, less salt. I have areas that get up to 23 or 24,000 microsiemens in this region. About 8 to 12,000 becomes toxic for livestock. Here, none of the water was over 3,000. That was not expected at all. We expected to have high salt concentrations and water that was not going to be consumable. In terms of salts. Now, there's other things up here that I'll talk about when we get to the EPA stuff. But we saw that 2 years running, we went back up and checked. We're still low. So that was the first thing that we came back to the BLM and said, you don't need to remove these things. These things are functioning ecosystems. The water, in most cases, is actually really good. We need to keep it and start to look at ways to incorporate that into the landscape and landscape design. However, the EPA went out there and looked at stuff. So when we talk about salts, we talk about sodium, magnesium. These are what are called cations. They're the positive charged ones. Well, they all have anions, your negative charged ones as well. So those anions, chlorine, so NaCl, table salt, sulfur dioxide, or sulfate, SO4, sorry, is there, OH is there, a couple of other ones. Sulfate's the one of concern, because if you have it high, it can cause stillborn in livestock and wildlife. They can get used to it over time, but you don't want it very high. So the thing that came out of the water work with the EPA, which was very interesting to look at, you see the difference in color just briefly. You see some ones that look more waterish, clearer, and then you see these really brown mucky ones. Well, the brown mucky ones don't have any sulfate in them. They have low conductivity. The other ones have higher conductivity, but they have high sulfates to where they would be a problem. Now, we were all excited we saw these results, right? So I go out and I talk to one of the ranchers up there, and he looks at me and goes, yeah. He goes, no, you never let the cattle drink on the clear ponds. You see all the cattails and everything around those. They don't even go there. They go to the dirty ponds. That's the good water. So they already knew. But we were confirming it scientifically as we went through some of these things. Soils, right? You have to have soil to have grass. You have to have organics to have that stuff. So those organics are carbon. Soil needs to be able to infiltrate and have water down. All the things you need for your houseplant, you need out here to grow as well. So in areas where we had undisturbed ground up there, or we had vegetated areas that had regrown some for reasons, we saw soil horizons. You see root cast and trace go down. You were getting infiltration. You could see soil development horizons. It's fantastic. The areas where nothing was growing look like this. One of my undergrads, I'm a big guy. One of my undergrads makes me look very small. And he was out there with a giant hammer and a post digger trying to get through this stuff to actually pull samples, because it's so compacted and so hard and just won't infiltrate. There is no soil development. That is bedrock. And so that's the problem that we've got out there, is we don't have soil development. We're not seeing those kind of things coming out of there. And lo and behold, that came through as well in the EPA data. The other thing that came into the EPA data, which was a little bit of surprise, is there's selenium up there and some other toxic chemicals, but they're not really any different than anywhere else out here in western South Dakota. They're in background range. So we have problems with selenium. We have problems with all these in most places and in surface water and soils. So it's no different. So the EPA is like, well, we're not going to mess with it. That's your natural system. So we have to look at ways to start to talk about how we can remediate that if we need to in design as we go forward. All right. The other thing we do, and this is the other half of what I do, I get to play with drones. I get to go and fly, but I don't play with drones just by myself. We have a couple of quadcopters and we do a bunch of work. We partnered with the South Dakota Wing of Civil Air Patrol. The reason being is they have a large fixed wing drone and high resolution cameras that we could go up and partner with them to go up and look at this landscape. At the same time, we're working with them to start to work on missing person case identifications using higher machine learning type models and those things. So it's a partnership to try and build, but it allows us to go out and fly this drone, and we were able to fly 30 square miles of this area with a drone. That's unheard of unless you're military and you have even bigger drones. So this is the Wingtret X1. You can see the size of it. That's Colonel Mike Beeson, and that is that's Dan. I can't remember Dan's last name. So they're both Civil Air Patrol. That's the size. We had spectators. Like I said, there are cattle out there, and they're always interested. So you use this thing, but it's a fixed wing. So vertical takeoff is something, if you've never seen it, is kind of an interesting thing to look at. So it literally goes straight up, then tilts, gets its altitude, gets up to the altitude you want it at, and then starts flying its regions and zones. So we could fly almost a square mile a day with a couple of batteries and one drone. Usually I would be able to do about 250 acres, maybe, not even that, 20 acres, sorry, in a day with multiple drones. So this was a really easy and nice approach, and a way that really benefited us as we did stuff. So what did it give us at the end? This is that nape imagery I talked about before. That's the drone imagery. So where we were at that half meter that I was talking about, we're now down to 7 centimeters. So all of a sudden, things on the landscape that you don't notice even when you're walking on the landscape started popping at us. We also had it in false color. That's why vegetation is red, because vegetation does photosynthesis. So it uses red, green, and blue light to do photosynthesis. It doesn't use near infrared, so it reflects that back. So what here you see is near infrared is the red band. So anything that's really bright red, that's vegetation. So you start to see these regions and areas where vegetation starts to come out, of course, right around the water bodies, but all of a sudden we started noticing in the erosional gullies and rills, that's where all the vegetation was up there. And we're like, that's different. Why would it be in an area that's being eroded out all the time? So we started to think about that and start to look at those things. You can see here also, you start to see that vegetation in green in a false color. Here you also notice the water, and you can see that amount of silt, that good water versus bad water. All of a sudden we can start teasing that out as well, because we can start to see those color changes and do that. Now if we can see them with our eyes, computer can definitely see them. We just have to train it to do that, right? So these are the flights we did. So we did 21 square miles in 24 and flew that twice. This is the data that we got for those areas. We did a subset of that in a very much shorter amount of time and a much cleaner set of maps, so we could get kind of a comprehensive look of just the area of interest. In 2025, we did 6 square miles. The difference is this was 7 centimeter resolution. We got this down to about 4 centimeter resolution. So we flew lower, had better resolution, could see some more things to see. So we're still in the process, I'm still in the process of looking at this to try and figure out what's going on with it. But we've started some of that analysis. The other thing that we did is something called photogrammetry, okay? Because the way these pictures, the way cameras work, you overlap all these cameras all over the place, you can pull and make 3D imagery of this, okay? That 3D imagery allows me to build an elevation model and start to look at areas where runoff is going, how the slopes and everything are, where vegetation is selectively choosing, and what's the gradient and all those kind of things. So I can start to do this kind of analysis. So here you can see that's the digital elevation model here, the height, and here's the false color, and then you look at the zoom-ins, and that's in 3 dimensions. It's not your eyes, you're still only in 2 dimensions looking at 3, but you can start to see depth. So you can see that there's a slope ridge right here and a drop off this high point that goes up here. You start to see these things, so we can start to do analysis on that as well. So in combination with that, I can go through and do analysis with big buzzwords, machine learning, but it's not AI. I have to teach it and then use it for what I want to look and find on the landscape. Pretty simple tool set, because what are we looking at? We're looking at areas with vegetation, the green, without vegetation, the tan, and water, which is the blue. And you look in here, you can see there's cloudy water in here. Here you can see it, it's a little bit reddish, it's harder to see, but you can see it, if you look closely at it, you can see that up there. So we can map that out. Why is that important? Well, it's telling us why is the vegetation there? Is it because there's water there or something else going on? And that's really the question we wanted to look at. And it didn't start to come to us until we got the high resolution imagery and started playing with it, right? So we can start to look here. Here's a map, that's that 3D elevation. These are contour lines. These are flow lines. So if you drop water down on one of those lines, that's where it's going to run. So we can map and create those and start to look and see all of this water is coming down here and moving down this valley, which visually we see that and understand it, but now we can train a computer to start to look at that and look at places where we start to see things that start to fit a model that we want to do for reclamation or for remediation. The other thing here, this one area here, which I don't have in full picture, is a flat. So all the water kind of drains into that, and then only one area comes off. So there's a lot of salt on there, but there's also a lot of vegetation on there. So you see both those things in that landscape because it's a low area. So that's where everything kind of settles out, and then the water evaporates, and you leave your salts there. All right? So why is this important, and what it looks at? That's Dr. Jennifer Walker sitting in one of the gullies that we were looking at over there that we identified using the remote sensing imagery and the drone imagery, and started to pull at it and started to notice in these areas of run is where you have vegetation. So this is the road. You can see the run right there where the vegetation is. Well, what's going on is we see erosion. So all of the fine dirt that can be moved by water is shifting and going down into those gullies. Well, those fines aren't dispersive clay. They're stuck sediment in the water. They move down. Salt's transported out. All of a sudden, you've got something that water will infiltrate and settle into. The other thing that comes with that is if there's enough drainage area around it, you get organic material, broken tree, buds, seeds, anything like that. They come down and they trap in those areas. And as long as the water level in rush isn't high, you can get soil development and organic matter. So that is the big aha takeaway from us, which really seems kind of logical when you think about it, but when you're out in the field looking at it, it didn't. And so we started to look at this and we're like, well, how can we take advantage of that when we're starting to do stuff and look at it as we go? Well, one last thing before I get to that. Little drama. So other interesting things we found. Remember I told you they did a previous study in the 80s and 90s? That's that previous study. The bright green, that means vegetation. It looks really good compared to the other areas. These are all of the experiments and what they did on all the plots. So you can see this one here, which is this one here, and this one here, which is that one there. They didn't do anything. That's your control. So we left it alone. Every other place that they did, they added the hydrochloric or the sulfuric acid, they added organic matter in differing levels and qualities. Well, really what it turns out they did, because to do that and add the organic matter, wood chips and manure, you have to turn the soil, right? So they went in and they broke that soil up. Well, when you break that soil up, you work it loose, you get infiltration. So you've automatically started to do infiltration. Then they added a little bit of organic matter. Lo and behold, just like our gully areas, you're starting to get development. They did one other thing that really helped this. Almost visible if you look, there's a fence around that thing. It wasn't grazed. 20 years, it's been fenced. I can make pretty good grass if I don't let it get grazed for 20 years. So you start to see these things, but it gives us ideas about how we can start to put this together. The other one over here, one of the other things that came up really curious, see my little heart right there? Or Africa, I guess, depends on how you look at it. The green around it, that's cattails. I mean, these riparian areas, when they get vegetation in them, they get taken over. But the reason is, same thing we're talking about here. You get shallow edges, low angles. You get those fine sediments dropping off at the end. All of the cattails and everything can grow. So you start to see that, and you see that out in that region. So again, reconfirming versus this water body here, which has a little bit on the shallow edge where it drops in right off of a drainage, but then all the rest of the way around, it's pretty stiff and pretty sheer. You don't get any vegetation growth. So we can start to play with these things about how do we connect and make all of this work together as an ecosystem without having to go in and basically bulldoze everything down and start from scratch with literally thousands of tons of topsoil, which was what their original plan was. All right, so how are we going to do that? Buns hunting. I might play on words because I'm an old crotchety professor and I have to do stupid things, so my kids back there can all cringe when I do stuff. So buns. So these are being used in sub-Saharan Africa right now. They're catchments, very low cost. The ones you see here on the right side, these are in Africa, and they're wind catches from water and precipitation. So you break it up, you get infiltration, you get soil development, organics flow in. We're talking about putting these in areas to help restore and stabilize landscape on erosional features and structures. I've got 2 undergraduates, one soon to be a grad student, who are working on the design in the civil engineering problem, who are working on the design to start to incorporate these into a way that is very cost effective for remediation. Now, is that remediation fast? Not a chance. If you've ever tried to grow and create soil out of nothing, it's years. It's a generational thing. But what it does do is it allows native species to establish and grow in those areas. We can do things like use sheep's waste, which sounds horrible. It's the waste wool off the back end of sheep that no one wants to buy because it's covered with a certain thing. But that certain thing is organic matter. But it's also seeds, it's all these other things. You put it down in there, it helps hold and retain water. We have a lot of it, and it's free, and allows you these soil developments in these buns. So that's really where we're pushing and starting to look for how we want to put this together. that we're on the third year of our project, and this is one of our big pushes back to the BLM is, don't go spend millions of dollars. Spend a small amount, keep this place really kind of a unique area, but stabilize it and keep it and make it sustainable for what's there and what wants to be there. So, year 1 and 2 findings, we talked about salinity and sodicity is the issue. It's the issue everywhere out here, but the vegetation that's up there lives, thrives, and grows. Western wheatgrass, those kind of things, they're used to this kind of environment. They can sustain and develop as long as you don't increase the salt on the landscape. So you manage it those ways. Riparian growth in selected regions, we kept seeing that. Here, you have less here. It really is based on the slope and flow into those water bodies. So if it was a mine pit that was dug like this with an access road out, you're going to have to do something if you want to get riparian growth on the edges. Or connect it to Middle Creek, which runs down below. So all of a sudden you have a sustained flow of water in these areas, and it will take care of itself. You'll get sediment transport. You'll get all the things that a healthy riparian ecosystem has. The development in most barren areas, those barren areas, the pictures I didn't show you, so I told you they screen the bentonite when they go out there. Well, what's in the bentonite are manganese nodules and magnesium nodules. So you guys have seen them, concretions. They're everywhere. So you go out on the tailings piles out here, and they're just concretions. So they have to be broken up, moved down if you want to do soil development on them. But they're really a very unique landscape. And I encourage you guys, it's right off 212. It's public land. Go up and see this place because it is something you will have never seen before. And there are people who live up there. I did a presentation for the Black Hills Biology and Ecology Workshop on Friday. And I had one of the gentlemen who was a student who worked with me who came up to me. He's like, don't get rid of it. I'm like, it's not the idea. The idea is to establish it and make it healthier. The discontinuousness. So what we want to do, so you can see here, there's a run for how these two are connected. A lot of these little ponds, they're not connected. That's not a natural system out here. It is East River in the glaciated terrains and the pingos, not having those connected. That's very normal. Out here, this is on the hill slope. Everything should be connected and flowing down. You should get that transfer of water, nutrients, sediments, all of these things working in concert together. So the other project here is how do we make it connected? And that's one of the reasons why we need that higher elevation model, so we can connect these things without causing severe erosion as we go down through. All right, so the conclusions for the work. Doing topography and sediment dynamics, we're looking at how all of this behaves together in a way that's usable. We're looking at total organic carbon. We want to find out, is there organic carbon up there, or can we set up a way to do that? How you do that, it's really simple. Get a soil sample, you cook it at 500 degrees C, which is about 1,000 degrees Fahrenheit. That burns off all the organics, and you weigh the difference between the two. You know how much organic carbon's in that system. So it's an easy way to do it, and I have grad students doing that right now with the samples. Two reasons. One, we can show that there is no organics in the areas where there's no vegetation, and there's good organics in the areas where there is vegetation, and we can show those pathways as we go down through. Sampling and analysis on those erosional pathways. You saw Dr. Walker out sitting in the middle of that one. That was one of our sampling, which is not easy, but we went through it and got it done, and we pulled those in, and now we're doing our analysis on all those to show they are low in salts, they have organic matter, and they allow infiltration down in that. So we have soil moisture sitting in those spaces. So we see all those things. And then we're going to develop a couple of restoration approaches that we'll turn back over to the BLM for this region on ways to start to do this. These two guys out there, there were more pronghorn out there. Pronghorn are a sagebrush obligate animal. They have to have sagebrush to survive, or they have to have vegetation that gives them the nutrients that they get from sagebrush. We are on the farthest western edge of sagebrush out here. We would go up there every day we were out in the field. There were at least 30 antelope. They're 15 yards from us staring at us. No one goes up there. So you see them everywhere. We saw bobcat, we saw coyotes, we saw snapping turtles, we saw, you name the wildlife that's up there and in these corridors. It is a wonderful place to go visit. And with that, I have no idea what time it is. Thank you, guys. Thank you. And I will take any questions you guys have. Yeah.
So I assume that BLM's your major funder?
We do work with the BLM, and we've also got projects with the NRCS as well. Similar but different, but this was funded by the BLM, yes.
So are you then just doing the science and then are going to turn over your findings so the reclamation is carried out by federal agencies, or can we be a part of this?
So we've been asked, the long story short is I started doing water quality analysis up there 8-9 years ago, and I became known as the water guy. So on the reclamation stuff, we're going to be involved on trying to work with that. We'll probably end up working with the civil engineering department at the school mines or at Montana Tech, because for those of you who don't know, the BLM here, we do have a field office, but the BLM here is the Montanas, the Dakotas, and so it's a much larger group that does the funding and the work. So we really work and partner together with them. But the intent is for us to help come in and keep feeding the science to the engineers, because engineers are great at designing stuff, but not always with all the knowledge that they necessarily need to have to do the right choices. And that's what scientists do, you know. So we break stuff when we design it sometimes. Do you have a question?
How much longer will it be estimated to mine?
Do you know the life cycle? Have you guys talked about the colony stuff? There is a lot of mine. So ACC has active areas up here, American Colloidal Company, that they're testing, exploring. They're not actively mining in the area we're at, but there still is bentonite in the area. But it's much different now with the regulatory requirements and how they have to go through. So you will never see this occur again. You will see much more, you remove the topsoil, it's preserved, you remove the bentonite, you recreate the same topography, the topsoil goes down, and you reseed with native seed, and then it's monitored for 5 to 7 years after that to make sure it establishes. So I don't know what the volume estimates are for the bentonite up there, I'm sorry, but I do know that reclamation is significantly different now than it was back then. Yeah.
So, in at least one slide, the photo showed livestock grazing. Who owns the service rights there?
So it's BLM land. So there's state land, there's BLM land, and there's private ranches. Dobesh Ranch is up there, 4K Ranch is up there. There's 3 or 4 large-scale ranches that are wrapped around this area. And then the BLM is a multi-use federal agency. So one of the things, the BLM owns those rights, but you can lease them to put your cattle on them. And that happens on a lot of BLM land out here. Actually, that's most of the BLM land out here. One of the main uses is for cattle grazing and stuff like that. So the rights are owned by federal government, but they're leased to the rancher. Longer term leases. Some of these guys have been there for 30 years. So
The entire area is public land? Study area?
yes, and that is because so here, all those hashed areas are public land. And if you notice, all of my little dots are public land. ACC, American Colloidal Company, really interested in what we're doing. But like any company, don't want to have information brought up on things that could potentially be detrimental to them. I mean, it's just common sense what they do. So it's not the company, it's the company's lawyers don't want us active in those areas. But they are a willing participant with us flying and doing everything else, and actually want the data, because it's not going to, I step from this line to this line, it's going to be kind of the same thing. So they're very interested in what we're doing and how we're doing it as cost-effective ways to help them manage their landscape better too. So they're pretty good partners with it, but no, they wouldn't let us go out and do sampling. Yeah.
So you said American Colloid, that's the larger of the two operations?
No, I think I think you guys are the larger, which is Halliburton. Halliburton. And the active mining is not here. The active mining is up into Wyoming and up into Montana is where a lot of the active mining is now. So, but it's really, it is very environmentally clean mining comparatively, especially for surface mining. You're not digging deep, you're not putting a hole in, you're really going in, getting the ore, base materials, and then recovering it and managing it out. And so it's very much that kind of step and process. So, any other questions? Yeah.
Quick question on imaging resolution.
Yep.
So the advantage of going from half meter resolution to 7 centimeters seems obvious. What's the advantage of going from 7 centimeter resolution to 4 centimeter resolution?
Okay. I'm a geek. Curiosity. We wanted to see what we could see. And start to talk about these things. So I've got other projects. One of the things we're looking at doing is using these sensors to start being able to pull soil moisture and nutrient cycling and actual vegetation identification out of these. And at 7 centimeters, I know what the vegetation is because I know the area. So I can tell the difference between sagebrush and rabbitbrush because I've been out there. 7 centimeters, a computer or a machine learning algorithm is not going to be able to differentiate those based on spectral signatures as much. And somebody tells you they are, I raise an eyebrow and be a little skeptical at some of these times. So that's one of the reasons why is science to get forward so we can get better as we go. Any other questions?
So then are you talking about doing reclamation or remediation on old sites? Or
The work we are doing specifically is on old abandoned sites. And so there's other groups out there that are very interested in the approach we're doing because old abandoned sites, there's no bonds or funds to clean these areas up. So trying to do it cost effectively on a bentonite site is one, but Belle Eldridge, if any of you guys know, that's an old lead mine, right? So you have acid mine drainage coming out of that. You've got lead, you've got all these other problems. So if we can come in and cost effectively help remediate that area, set these catchment areas up where you get natural filtration and sediment systems, that's the longer term goal. So it is, for us, the work we're doing is abandoned, but we have a lot of large consulting companies that are looking at what we're doing because they're very interested, because this is much more cost effective approach than it is expensive to remediate a mine site. So even when you do everything right, and you don't have toxic chemicals sitting in the landscape. It is expensive. Yeah.
I have a follow-up. So your catchment design, is that then the present soil that's been broken up and mounted and shaped in such a way to capture moisture and organic material, or are you importing some topsoil?
So no topsoil. The whole idea is to build from the natural position and build and develop there. So you can bring in additions, organic matter, seed bank, those kind of things to help, but you want to keep it very natural. So one of the things everybody's talking about is, well, you can come in and bring wood chips in. And it's like, that's great, except for wood chips have other things in them. So we're looking at what's called biochar. So you take those wood chips and you cook them down to where they're basically carbon and coal, and they're really good at cleaning and soaking up water and allowing microbial communities and fungi to pop. And that's where you get your soil development. Relatively, yes. Yeah. Any other questions? Yeah.
You mentioned a lot about measuring the pH. Do you guys have any concerns for other factors that in the water, suspended solids?
Yeah, so when you talk about total suspended solids, TSS, that's usually a pretty good solid proxy for salinity. And really what it is it's what the salts are. When I say salts, everybody's like, okay, sodium, right? But it's not. It's sodium, magnesium, it's metals, it's chromium, it's all of these metals in that suite. Those are your salts. So up there, that's why we had the EPA come in. So we could look at a full baseline of anything that has a water quality standard. So we can sit there and say, do we have to look at something else? And selenium was the only one that came up. Yeah. Little uranium here and there, but yeah, we have that out here. But it was not higher than background. So, any other questions? Yeah.
Is there nitrogen found
Nitrogen? Yes and no. So there is nitrogen in the form of nitrates because that's what plants need to eat. So it gets found and worked into the soil, and the microbial communities there, some of the fungi and microbial communities that are in the soil, they generate from nitrogen in the air, they generate nitrates down into the soil. So that's how they self-sustain, these plant communities, is it's a very symbiotic relationship and allows that to be done. So nothing mineable or anything like that, but yeah, there is nitrates down there. Yeah?
In the riparian areas where the reeds are reintroducing themselves, do you have any idea how quickly topsoil is being?
No, and it's a really good question and something that we have talked about in terms of this is a big unknown. So it's one of the reasons why the next step is to put this out there and start to monitor it and see what we're going to get and how it's going to succeed. And then looking at these areas, cattails do a fantastic job of trapping sediment flow and really building that up. You can watch ponds with cattails sediment out in years, which is a fantastic soil development situation in those things. But no, we don't have a quantifiable number for what's being done. So, yeah.
Does this go on to an endless time? Or?
For us?
Yeah. Is there
No, because, well, I'm old, so eventually I'm going to retire. So, but the work and the development, yes. But the monitoring and those things, so the idea here is you start them, you get them going, and it kind of becomes a self-propagating ecosystem, and it works out over time. You may have to do a few things and adjustments, but then it's the BLM who's going to go out and monitor it and do those kind of things as part of their job, not a research scientist agreement or system anymore. So it's like any ecosystem for sustainability. If you don't pay attention to it, then somebody does something wrong, you're going to have to go fix it. So in that aspect, yeah, it's going to be kind of a lifelong process.
is BLM funded?
Yes. It's a sticky wicket because as we talk about stuff like this, hardcore science is not a prime driver for these things. So the word sustainable doesn't really work when you go in for funding to do these kind of things. There is funding for projects. You just have to work it to where it's the benefits or the desires or the needs for the funding agency right now. So for us, we're looking at rangeland health as a new project. Why? Because that's improving grasslands and forage. So we're looking at ways to do that with high resolution remote sensing and field sensors to proxy everything together. So there are still ways to do this stuff. You just have to be a little more inventive. And the ranchers and the people in the communities, they want this stuff because this is their livelihood. This is their sustainability. I've been doing this kind of thing for 30 years. 30 years ago, mid-90s, I would have had this conversation. I would have had a bunch of people in the room going, you're full of it. Now, everybody understands it. They see it because they've seen it on the landscape. They've seen it with their cattle. They've seen it with the increasing drought. They've seen the changes on the landscape. This is their livelihood as well, and they want to make it right and sustainable for the next generation and the next generation. So I do see a change in mentality on the local level, which is good. Any other questions?
Any lessons learned from the wildland?
Yeah. Life will find a way is pretty much the best thing I can tell you. When you go out and you walk out after a hard couple rains, 2019 we were out on the clay pans, and you walk out there and you're walking around. It's got a couple inches of water sitting out there on these hard clay pans, and you look down and there are fish on these clay pans, and you're like, you're going to be gone in 3 weeks. Life will find a way. They will work if the conditions are there. They will come in. It may not be what you want, but it will come in and rework and establish in those areas. And so up here, this is the moonscape. I mean, everybody talks, oh, it's barren, it's horrible, except for the people who've gone up there and seen it, and then they're like, oh no, this is kind of a wonderland. There's a tuck corner on one of the ponds where you can see There's just a row of where bivvies sit and duck hunters sit every season. Just it's the perfect landing site and blind area for ducks. So you see those kind of things. People see it, they just don't tell anybody about it. So I do think the takeaway is life will find a way. It just may not be the life you want there, or in a way that you want it. So it's that mix in play as you look at stuff over time. You talk to a rancher, he wants those impoundments cleaned out because it's full of mosquitoes and they're annoying and they want grass. You know, they want enough water to consume, but they want grass. And some of them have a little bit of dangerous because of those slopes and pitches. You talk to a wildlife ecologist or someone who wants to fish. I had a gentleman after the Friday conference who talked to me. He's like, I'm from Black Hills fly fishing. He's like, is there anything up there that we can look at for stocking and doing those kind of things in that creek to run to start to establish? So yes, those things are there, you know, and none of those are native species. So you start to see that play out as well. Any other questions? Well, thank you guys so much.
Thank you all again for coming. Like I said, we do this every third Tuesday. So next month, the date is April 21st. And the presentation will be from Dr. Harriet Scheppers and part of the South Dakota Mines Choir. Dr. Scheppers is a native of South Africa, and his presentation is going to be about the music of South Africa, some of which will be performed by part of the South Dakota Mines Choir. So hope to see you on April 21st.